What is VOD? Thank you for your question. VOD is an abbreviation for velocity of detonation. It is the speed at which the shock wave front travels through a detonating explosive after it has been initiated by a detonator or booster. Why does VOD need to be measured? Thank you for your question. VOD is cited by explosives manufacturers for any given explosive under any given condition. VOD needs to be measured because it is the only way that the manufacturer or consumer of explosives can determine whether or not the explosives are detonating properly. VOD influences how the energy is released from the explosive as a combination of shock energy and heave energy. This affects the fragmentation and throw of the blasted rock and the cost to the mine of mineral extraction. The VOD of an explosive is dependent on the explosive's characteristics such as formulation, density, particle size, diameter, and degree of confinement. It is also dependent on factors adversely affecting those characteristics, such as ingress of water or other impurities, static pressure, and dynamic pressure. Only VOD recording can essentially show what is happening with the explosives in the blast holes. Who needs to measure VOD? Explosives manufacturers or explosives purchasers? Thank you for your question. The short answer is both. Any company who is either selling or using explosives should and can easily check the quality and performance of the explosives under real-life blasting conditions. Explosives manufacturers measure VOD to ensure that the explosives being delivered to their customers are performing as promised under the customer's specific blasting site conditions. Explosives purchasers, such as mines, quarries, and blasting contractors, measure the VOD to ensure that the explosives they are buying are working correctly to produce good fragmentation and throw, thus minimizing downstream processing costs and maximizing the whole operation's profitability. Which MREL VOD recorder is right for me? Thank you for your question. MREL manufactures the three world's leading continuous explosives VOD recorders that will serve different purposes at different price points. For your information, currently over 1,000 MREL VOD recorders are being utilized by over 400 companies and governments in 80 countries. If you only wish to do a spot check of VOD on explosive samples or on explosives loaded into one blast hole per blast, then the world's most affordable continuous VOD recorder, that's MREL's HandyTrap 2 VOD recorder, should be your first choice. If you also wish to test the VODs in multiple blast holes per blast and determine the accurate delay times between blast holes, then the world's most popular continuous VOD recorder, that's MREL's MicroTrap VOD recorder, should be your first choice. Finally, if you also wish to test VODs in multiple blast holes per blast, or in blast holes detonating simultaneously, or if you wish to record other blasting information, such as that from near-field accelerometers and blast overpressure sensors, then the world's most capable continuous VOD recorder, that's MREL's DataTrap 2 Data VOD recorder, should be your first choice. What is the difference between MREL's HandyTrap 2, MicroTrap, and DataTrap 2 recorders? Thank you for your question. The The world's most affordable continuous VOD recorder is the HandyTrap 2 VOD recorder. It is a continuous VOD recorder that can easily determine the VOD in a single explosives sample anywhere along the explosives sample using a factory-calibrated sensor called a VOD probe rod. It can also easily determine the VOD in a single blast hole of explosives per blast, everywhere along the column of explosives, using a factory-calibrated resistance cable called VOD probe cable. The world's most popular continuous VOD recorder is the MicroTrap VOD data recorder. It can do everything that the HandyTrap 2 can do, plus it can measure VODs of explosives in multiple blast holes per blast and also display the delay times between those blast holes. The world's most capable VOD recorder is the DataTrap 2 Data VOD recorder. It can do everything that the HandyTrap 2 and the MicroTrap can do, and since it has 8 channels, it can record the VOD in 8 times as many blast holes as the MicroTrap. Plus, because of the 8 channels, it can record the VODs in up to 8 blast holes or explosive samples detonating simultaneously. Additionally, the DataTrap 2 is the only VOD recorder in the world that can also be used to record VOD at the same time as near-field accelerometers, blast overpressure sensors in air, and underwater pressure sensors, such as those used to determine pressures impacting detonators, boosters, and bulk explosives in blast holes delayed to fire late in the blasting sequence. What is the difference between VOD probe rod and VOD probe cable, and what are their respective applications? Thank you for your question. VOD probe rods are factory-calibrated sensors with a known resistance per meter. They are used to test the VODs of explosives samples. MREL manufactures various types to extremely tight tolerances in lengths from 20 centimeters to 3 meters long. Some VOD probe rod types are rigid and can be pushed into those explosive samples that are expected to detonate at 2,500 meters per second or higher. Some VOD probe rod types are of a softer material that can be taped to the outside of an explosive sample that is expected to detonate at less than 2,500 meters per second or even deflagrate. VOD probe cable, on the other hand, is a strong, lightweight, flexible, factory-calibrated resistance cable with a known resistance per meter. It is used to test the VODs of explosives loaded into one or more blast holes. What are the types of VOD probe cable, and which one is most suitable for my use? Thank you for your question. MREL manufactures 4 different types of factory-calibrated VOD probe cable. The first type is VOD probe cable HT, which can be used by any of MREL's VOD recorders. It is provided as a ready-to-load individual spool containing a length of 30 meters, with 12 spools provided in each box. It is the only VOD probe cable type that the HandyTrap 2 recorder can use to test the VODs in one blast hole. The remaining 3 types of VOD probe cable are all provided in pull-out boxes for ease of use on the blast. Each pull-out box contains 1,000 meters of VOD probe cable that can be used in any length in one or more blast holes. VOD probe cable green is the world's most popular continuous resistance cable for VOD recording. It is a green color. and it is typically the go-to calibrated resistance cable for VOD recording with the microtrap and data trap 2 recorders. VOD probe cable K Kevlar is the world's strongest continuous resistance cable for VOD recording. It is used in blasting situations that have a large amount of ground movement prior to the detonation of the product in the hole. This type of VOD probe cable is often used in hard iron formations as well as in cast blasting applications. It is a dark green color with a white stripe. VOD probe cable LR Blue has a lower resistance per meter than the other VOD probe cables. This allows even more blast holes to be recorded per blast by the microtrap and data trap 2 recorders. This blue-colored cable is often used at mines with very deep blast holes for VOD recording in multiple blast holes per blast. What is the difference between MREL's VOD recorders and the OZM VOD 815? Thank you for your question. The OZM VOD 815 is a point-to-point time recorder and will display the average velocity between discrete points located in the explosives column. It relies solely on the accuracy of the measured distance between the two or more points and the speed and accuracy of the timer. This method is also called the start-stop timer method or the discontinuous method for determining explosives VOD. Point-to-point systems such as the OZM VOD 815 are generally only used on explosive samples, not in blast holes. They can work very well for determining the average VOD between two or more points in an explosives sample. However, the accuracy of the VOD result is extremely dependent on the perfect distance placement and orientation of the tips of the fiber optic sensors in the explosives by the operator. If the sensors are not placed at the precise distance apart as selected in the OZM VOD 815 operations menu, or are placed at different angles or depths into the sample, the VOD readings cannot and will not be accurate. This makes this recorder very dependent on the accurate measurement of location and placement of the fiber optic sensors, even under controlled conditions, such as in samples of explosives. It can be done for explosive samples, there's no doubt. In contrast, MREL's continuous VOD recorders use VOD probe rods in samples of explosives. VOD probe rods do not require placement accuracy or measurements. Where the OZM VOD 815 can record up to 8 data points in a meter-long sample of explosives, the MREL VOD recorders can record a minimum of 200 data points per meter and up to 2,000 data points per meter of explosive. This allows the change in VOD along the explosive sample to be recorded easily. For use in mining or quarrying blast holes, the OZM VOD 815 requires running from 2 to 8 optical cables to the blast hole being tested. The ends of the optical cables, as mentioned earlier, must be placed at carefully measured positions within the explosives column in the blast hole. This is so that the distances between the optical cable ends is known exactly. Obviously, requiring multiple fiber optic cables and then positioning the tips of them at exact positions inside the blast hole explosives column is subject to error. Even if you could place them precisely in the blast holes before loading with explosives, imagine what happens to those positions when loading the explosives into the hole. In contrast, MREL's continuous VOD recorders use one length of VOD probe cable in explosives in blast holes. VOD probe cable does not require placement accuracy or measurements. MREL's continuous VOD recorders do not suffer from the inconvenience of running long lengths of multiple signal cables per blast hole, nor do they suffer from the very likely inaccuracy in using the point-to-point method. The MREL VOD recorders can record a minimum of 200 data points per meter and up to 2,000 data points per meter of explosive in blast holes. This allows the change in VOD along the explosives column to be recorded easily. What is the difference between MREL's VOD recorders and the ShotTrack VOD 305? Thank you for your question. Similar to MREL's VOD recorders, the ShotTrack VOD 305 is a continuous type of explosives VOD recorder. However, unlike MREL's VOD recorders that use factory-calibrated precision resistance cables, the ShotTrack VOD 305 uses the time domain reflectometry technique. The short form for that is TDR. It's used for determining the length of a consumer-grade coaxial cable. It sends an electrical pulse down a coaxial cable and waits for the reflected signal from the end of the coaxial cable in the explosives to return. The ShotTrack VOD 305 records the total time it takes, starting from when the pulse is sent until the time the reflected pulse from the end of the cable arrives back at the recorder. If one knows the speed of that specific pulse in the cable being used, then one can easily calculate the length of the cable. The TDR technique used by the ShotTrack VOD 305 is not new technology. In fact, TDR was not initially intended for use in explosives at all. It was developed by Los Alamos National Laboratory in the mid-1900s. It was developed to measure the position of a shock front along the ground from a nuclear explosion. Those blast pressure waves are magnitudes slower than explosives detonation velocities, so the TDR technique's relatively slow maximum recording speed was suitable for Los Alamos's intended application at that time. As an aside, Los Alamos uses MREL's VOD recorders when testing explosives VOD. There was an earlier commercialized TDR-based recorder called the VOD-R that was marketed as an explosives VOD recorder. It was manufactured by EG&G in the USA, and it was in use in the 1970s and 1980s by the industrial explosives industry. It was essentially rendered obsolete by the subsequent development and commercialization of MREL's resistance-based VOD recorders in the early 1990s. To more fully answer your question, I thought I'd take this time to provide my understanding of the problems and limitations associated with explosives VOD recording using the TDR technique. First, I'll summarize some of the key limitations of the ShotTrack VOD 305 when compared to MREL's VOD recorders. It is unsuitable for testing VODs in explosive samples. It has a relatively slow recording speed. It has a relatively short maximum length of VOD recording cable that can be used. It has a requirement of the operator to self-calibrate the cable used, and the cable used is heavy to handle. Okay, I'll explain further. The ShotTrack VOD 305 does not have the capability to test the VOD in explosive samples. With an advertised recording speed of only 256,000 samples per second, its recording speed is far too slow for that application. Now, to ShotTrack's credit, it is my understanding that ShotTrack does not advertise use of their ShotTrack VOD 305 for testing explosive samples. MREL's recorders all record a change in resistance with time. Unlike TDR, resistance measurements are instantaneous and can be performed at any time, and accuracy is only limited by the recorder's recording speed. In contrast, the TDR technique is limited in its maximum recording speed because it has to wait for the reflected signal from the end of the cable before it can send another signal. In the intervening time, no data can be collected about the VOD of the explosives. As a result, even the world's most affordable continuous explosives VOD recorder, MREL's HandyTrap 2 VOD recorder, records at about 4 times the speed and data points per meter than the ShotTrack VOD 305. The world's most popular continuous explosives VOD recorder, the MicroTrap VOD data recorder, records at 8 times the speed and data points per meter than the ShotTrack VOD 305. The world's most capable continuous explosives VOD recorder, the DataTrap 2 data VOD recorder, records at 40 times the speed and data points per meter than the ShotTrack VOD 305. Now, the ShotTrack VOD 305 has a maximum cable length limit of 300 meters. This includes the distance from the bottom of the first blast hole being monitored back to a safe location of the recorder itself. Contrast that to MREL's MicroTrap, for example, which can use up to 1,000 meters of VOD probe cable LR blue in multiple blast holes per blast, plus a practically unlimited length of coaxial cable back to the safe location of the recorder. This shortcoming of the ShotTrack VOD 305 could be a huge problem in some of the larger energetic blasts, where the recorder may need to be located a long distance from the blast to protect it against fly rock impact and thus recorder destruction. The user of the ShotTrack VOD 305 must calibrate the VOD cable being used before each test. This is to determine or confirm the speed of the ShotTrack VOD 305's signal in the cable, as discussed earlier. It is recommended by ShotTrack that 300 meters of cable be unspooled and pulsed by the ShotTrack as the calibration procedure before each test. But how is the operator to know that he has exactly 300 meters of cable attached to the ShotTrack during the calibration process? Is the operator expected to measure it physically? Also, if a box of consumer-grade coaxial cable says 300 meters on the box, it doesn't necessarily mean there's 300 meters in the box. If the box, for example, contains only 270 meters and not 300 meters, and the operator tells the ShotTrack VOD 305 that it's testing 300 meters during the calibration procedure, then the ShotTrack's VOD results will be off by a whopping 10%. It seems an involved process and potentially subject to error. In contrast, MREL's VOD probe cable is provided factory tested and factory calibrated, ready to use immediately. The weight of the cable used in the ShotTrack VOD 305 is about 5 times heavier than that used by MREL's VOD recorders. That's the VOD probe cable types. So that's approximately 50 kilograms weight versus 10 kilograms for 10,000 meters of VOD probe cable. Now, in summary here, ShotTrack markets its ShotTrack VOD 305 as the next generation of velocity of detonation monitors. I believe the phrase next generation is better left to advancements in technology, not repackaged old TDR technology from the mid-1900s.